Hello everyone, welcome to another Python Basics video. In this video, we're going to be solving a 2004 J1 level question from the Canadian Computing Contest, and the problem reads as follows. Gigi likes to play with squares. She has a collection of equal-sized square tiles, and Gigi wants to arrange some or all of her tiles on a table to form a solid square. And we're to determine what is the side length of the largest possible square that Gigi can build. For example, when Gigi has 9 tiles, she can use them all to build a square whose side length is 3. All right. Whereas if she only had 8 tiles, the largest square that she can build has a side length of 2. And we're to write a program that inputs the number of tiles and then prints out the maximum side length. And we're allowed to assume that the number of tiles that is inputted will be less than 10,000. So to start off, we're going to handle our easiest part first, which is the input. So I'm just going to say input, and we're going to get the number of tiles, and the variable name that I decided to choose was tiles. And we're going to grab an input. And what we want to do, since this is numeric, I want to convert that result of an input function to our integer. So I'm running the typecasting function called int, and let's take a little note. It's a typecasting function that converts its argument to integer. Alrighty. Now, at this point, we're going to do some processing to figure out the number of tiles. With those number of tiles, the maximum side length we can get, and then we're going to have some sort of an output. So let's say that when we do our output, we're going to print a formatted string of the largest square had a side length, and then we'll add answer and a period here. So we're going to say that the largest square that had a side length of whatever we calculated in our processing, input it right here. We're going to insert that into our string and call that a variable of answer. So we're going to need to calculate answer. Okay. And just to note that for this problem, if you didn't understand the mathematical solution to find the answer, we had to use a square root onto tiles to get the most optimized side length for the possible square when we're given the number of tiles. So to do so, we can say that, well, the answer is equal to the value of tiles that we have, and we can give it an exponent of a half. A square root is a fancy way of writing out an exponent of a half, and we can express it like so. But what I want to do right now, I will actually comment this out and show you an alternative way to do square root. And in this scenario, we're also going to need to do a floor, because we can't have partial square or partial answers, because if a square root is not possible, we're going to need to round down to say that we can only create a square of this big, and it's going to only have a side length of a value rounded downwards. So let's see how to do that. But for us to do so, I like to write something called import statements up at the top of my program, and say that we're going to go from our math module. We're going to be importing 2 key function. First is the square root function that we need, and we're also going to import the flooring function, which helps us to round down any number to a nearest whole number downwards, no matter what the decimal place was. So then our answer is going to be changed to first us square rooting tiles and taking that result, and we're going to be flooring it. So we're going to update answer again to said flooring the answer. Now this could also be easily written in one line to say that answer is equal to the floor of the square root of tiles, so that you can do some composition of functions here to execute square root onto tiles first, then you apply the floor function onto the result of the square root of tiles. But here I'm just showing you that we can update our variable like so, by updating even to a manipulated version of itself, and then grab its new value. So we have that made. Let's save our code and see what happens. I'm going to run Python. This file is called vid03.py. And right now it is executing line 23. It is waiting for a value. So if I were to input 9, it's going to say that the largest square had a side length of 3. Let's try running that again. We have 8 tiles. We can't create a perfect 3 by 3 square. The best square that we can make is actually 2 by 2. If I were to square root 8, you're going to get a decimal based answer, and we can't really snap or expect Gigi to snap our squares into perfect decimal sizing. So when we do execute it with the value of 8, we're going to get the largest square had a side length of 2, and that is the result of using the floor function. Okay. So in this video, we learn how to write import statements. It is best that if you're not going to use everything from a module, it's best to use the from import nomenclature. We're going to say from a module name that we have interest in, we're going to target the functions and, well, really things that we want to import into our Python program. And then we can apply those calculations and use those functions throughout our processing section of our code. And then we can output by using a really nicely, neatly done formatted string by using fstring. As always, thank you for watching and stay classy.